Okay. All right. By the way, I want to highlight my little gadget here. I don't know if I highlighted before. I'm just having so much fun with it. It's called a DG Root. It's a stylus for my iPad. Okay. One of my kids got it for me. Guys, it's the best thing ever. All right. So A1 plus N minus 1 times D. A1 is the first term, always. N is the term number. So wherever you find on N, you want to go ahead and plug in the term number. And then D is the common difference. And the common difference is that number that is added over and over again to each term to find the next one. All right? Now, let me show you guys a quick little problem involving finding the nth term of an arithmetic sequence. Now, guys, there's a quick little problem, okay? For this one right here, it says A1 is equal to, hold on a second, -2. Oh, wait a minute, I'm writing the wrong thing. Find the nth term of the arithmetic sequence. Okay, you know what? Let's just keep going with it. D equals to 4. All right, this one, rather than finding a specific term, they want us to find the nth term. In other words, they want us to come up with a formula to calculate any term in the sequence. And then I'll do one with a specific term in a minute. So they give you the first term, they give you the fourth term. So you want to find an nth term formula, a general formula to calculate any term in this sequence. So the nth term formula will be AN is equal to, you're going to substitute -2 for A1, and then you're going to substitute +4 for D. And of course, you're going to simplify this out. Distribute the 4 to get 4n minus 4, which simplifies to -6 plus 4n, or better yet, 4n minus 6. So this is the formula you would use to calculate any term in this sequence where the first term is 2 and the common difference is 4. Now, let's say I wanted you to find, let me erase some of this. I wanted you to find the 300th term. So now, guys, that we have the general formula down here, all we do is go into that formula and substitute 300 in for n. So 4 times 300 minus 6, and then work it out. 4 times 300, 300 is 1,200. 1,200 minus 6 leaves you with 1,194. So this would be the 300th term in that sequence. Questions? No? All right, guys. So here comes the next part of this. So for this one right here, they want you to find the 90th term if you are given the following sequence. And the sequence is 1, let's see here, -2, -5, and of course these sequences, they keep going on and on to infinity, right? So guys, they're only telling you to find the 90th term. So if you go into the formula, wherever you find on n, you're going to substitute 90 in for it. So we're going to do a sub 90, this is a subscript right here, equals to the first term. What's the first term in this sequence, guys? This is the first term. So that's 1. That's right. Now, 90 is the term number. The term that you're looking for is the 90th term. And then you need a common difference. What is the common difference for this problem? What is that number that you have to add every single time to each number to get the next one in the sequence? This one is going to be -3. So you grab your calculator, guys, and throw this on a calculator. 1 plus 89 times -3. 3 times 90 is 270. 270 minus 3 is 267. 267 is a negative, so this is going to become 266. Is that right? You guys are good? All right, guys. Next question. So that was number 2 right there. Number 3. This time right here, I want you to listen carefully. They want you to find the first term and the common difference given the 8th term is 8, the 20th term is 44. So they want you to find the first term because they didn't give it to you. And they also want you to find the common difference because they didn't give it to you. And then they want you to find an nth term formula. What's the nth term formula for this sequence right here, where the 8th term is 8, and then the 20th term is 24. All right, guys. So we're gonna go in the formula again, plug in what we have. What do we have? We have n. We also have a sub n. So when we plug it into formula, we're going to get 8 is equal to, we don't have a1, plus 8 minus 1, because n is equal to 8, since we're looking for the 8th term, times d. Okay, so this will simplify to 8 equals to a1 plus 7d. Now, we're going to go ahead and go to the second one. The second one, which is the 20th term, is 44. We don't know the first term. Now, the term number is 20, as in the 20th term is 44. So we do 20 minus 1 times d, because we don't know the common difference. So we're going to kind of like simplify this out. And when we simplify it out, guys, we get a1 plus 19d. Now remember, our goal here is to go ahead and find the value of a1 and d. So do you guys see what we have here? By the way, guys, a what?
A system of equation.
Very good, Lee. Very good, Sarah. It is a system of equation, guys. Now, if you can't see the system, there's one of the equations right there, and then the other one is at the bottom. By the way, guys, if you cannot see the bottom of your screen, like Presley said last time, zoom out the screen, okay? Was that you, Presley, who said that? Okay, I don't remember. But guys, let me erase some of this. Okay, I'm gonna erase some of it. You know what? Let's just go to the next page. Shazam. Okay, so guys, here we go. 8 is equal to a1 plus 7d. That's one of the equations. And then the other one is 44 equals to a1 plus 19d. There's your system of equation, guys. So now we're going to solve for a1 and d. So I'm just going to subtract. 8 minus 44 leaves me with negative 36. The a1's cancel out. 7d minus 19d is going to give me negative 12d. So I divide both sides by negative 12. So it looks like d, which is the common difference, is 3. Now, we're going to go ahead and go back and substitute the dn to find the value of a1. So we're going to plug in 3 for d, work it out. So we get 8 equals to a1 plus 21, subtract the 21 from both sides. So a1 is equal to a negative 13. So there's your a, there's your d. Now we're not quite done, because they also want us to figure out the general term formula, the nth term formula. Now, to figure out the nth term formula, now that we have a, we have d, we can go ahead and go plug them in. And the nth term formula, guys, remember, is basically a general formula you're creating to find any term in the sequence. So you cannot plug in a value for n, but you do have a value for d, and you have a value for a1, so you go in and plug in those values in. a1 is -13. We don't know what n is, but we know d is 3. So we go ahead and simplify this formula out by distributing the 3. We get 3n minus 3. So the general term formula will be 3n minus 16. All right, guys, how are we doing? Any questions? No? Okay. So now, guys, we're going to go into finding the sum. Find the sum of the first, let me see here. Find the sum of the first, I'm writing first, nth term of an arithmetic sequence. So we're going to be finding the sum, guys. Essentially, we're going to take every single term. Okay, Sarah, I am seeing your question, but I don't recall what the beginning was. Let me see here. Could we have found the slope? Okay. By the way, Sarah is saying slope. She's referring to this as the slope. The rate of change is right there, guys. 3. Okay. 8th term of 8 and 20th term is 44. How so, Sarah? Mm-hmm. Divide by 20 minus 8. Oh, I see what you're saying. Oh, okay. Okay, Sarah. Now calm down, Sarah. Shazam. Okay. I see what you're talking about. The rate of change formula. As in, let me see here. If you have A1, A2, and the value of A1 is equal to, what was it? What was the first one? Let me check your notes here. It was 8. And the value of the second one is, let me see here, 44. Could you just have done this? As in f of a sub 2 minus f of a sub 1 divided by a sub 2 minus a sub 1, which would give you the 44 minus 8 over the, what was the term number? 20 minus 8. So 44 minus 8. Wait a minute, I think I'm doing the wrong thing. What was the value? Wasn't the value of the 8th term 8? Yeah, it was. Okay, so anyways, 44 minus 8 is 36. 20 minus 8 is 12. So guys, look at what you end up with. 3. Yes, absolutely. That would have given you the slope right there. So in other words, Sarah is talking about a parallel between these arithmetic sequences, okay, and slope, guys, linear equations. This is a linear equation. This is nothing more than a linear equation. And remember, when we first started this, what did we say? This is simply a function. So we could have actually taken this. Let me use a different color. I don't know why I'm not using the colors today, guys. Okay, so we could have actually taken this and rewrite it as f of n equals to 3n minus 16. Now, because you guys are not very familiar with the n variable being the independent variable, you could have done f of x equals to 3x minus 16. Isn't that the same thing? Absolutely. Way to make connections, Sarah. Very good, very good. Nice. Now, I have to retrace my thoughts here. I don't remember where I was at, okay? All right, so let me go ahead and backtrack a little bit. Although, you know what, I should just go ahead and erase this because there's a lot to backtrack here. I'm just undoing everything I did just now, okay? Because guys, let me tell you, the technology is so powerful that I am able to do this. Very good. All right, so now let's get back to our work. How do we find the sum of the first nth term of an arithmetic sequence? So in the case of the arithmetic sequences, guys, if they want you to find, let's say, the sum of the first 4 terms, the sum of the first 20th term, is there a formula for it? Rather than having to sit there and add these terms individually? Yes. No, Lee, we're still on 12.2. 12.3 has to do with the geometric ones, okay? So the formula we use to calculate the sum of the first nth term of an arithmetic sequence is this, guys. S sub n, S for sum of the nth term is equal to n divided by 2, the number of terms. So if they wanted you to find the sum of the first 8 terms, the n would be 8. Just like we just talked about the previous formula, everywhere you find an n, you go ahead and plug in the term number, okay? Times a1, which of course is the first term, and then an, which of course would represent the last term. Now, guys, if we were to go ahead and take this and rewrite it in another way, we could rewrite it as n times a1 plus an, and all of this would get divided by 2. So these two formulas right here, they're exactly the same thing, all right? So to calculate the sum of the first nth term of an arithmetic sequence, that's the formula that we use. Next, here comes a problem, guys. For this one right here, the sequences. Now, when we're adding the terms of a sequence, guys, I like to refer to it as a series because this involves addition, okay? Unlike the sequence, you're looking at the terms independently. So they are discrete. Here, no. By the way, there's a math class called Discrete Mathematics, okay? But anyways, further on. Okay, guys, so 2 plus 4 plus 6. And then this sequence carries on to 70. So the 8 of the 2 would represent the first term. The 70 would represent the last term. So we're missing one thing. We don't know how many terms we have to find the sum of. They want us to calculate the sum of the series right here, the sum of the sequence. Okay, but how many terms are they going to? 70 is which term in that sequence? So what are we going to do to figure out how many terms they want us to find the sum of, guys? How do we do that? Anybody? Oh, come on, guys. All right. Now I want to expedite this because it's already 9:43. So let me go ahead and just talk to you. So they give you the nth term already. So you go into the an formula and you plug it in. A1 plus n minus 1 times d. Now, could you just have taken this and plugged it into the sum formula? N over 2 times a1 plus a sub n. A sub n is this. Could we just plug it into the formula? Yeah, we could just go ahead and drop that in there. Okay, plus n minus 1 times d and do a little bit of work. So you get n over 2 times a1 plus n minus 1 times d and do it all in one step. But for some of you, I think you would prefer to go ahead and write out the information. So I'm going to go back and just figure out what term number the 7 is. the 70 represents. So let's go ahead and work it out. So the term, the Nth term is 70. Okay. Now we have the first term, which is 2. I see what you're saying, Sarah. Hold on. Okay. N minus 1. We don't know what it is. We don't know what the n value is. So we're just going to leave it like that. Now, guys, what's the d value for this problem? What's the common difference? The common difference is 2. That number that you keep adding over and over again. Now, I see what you were saying, Sarah, but you still have to add the 1 to it, okay? Now, we're going to go ahead and subtract the 2. Okay, so we get 68 is equal to, actually, I didn't even have to do all of that. But anyways, we'll go with it, guys. 2 times n minus 1. And the reason why I decided to do it this way is because I'm following what Sarah's saying on here. I'm dividing both sides by 2. So I'm going to get 34 is equal to n minus 1. So here's the part that you missed out on, Sarah. You have to add 1 to it. So that gives you 35. So basically, guys, 70 is the 35th term in the sequence. So we are finding the sum of the first 35 terms of the sequence. So now we're just going to go back and plug in the formula, okay? So in the formula, S sub n, actually, that's supposed to be an n right there. You know what? Let me just do this. S sub n is equal to n over 2 times a1 plus an. We just figured out that we're looking for the sum of the first 35 terms. We just found n. So that's going to be 35 divided by 2. The first term was 2. The last term was 70. So now we're going to work it out. So 35 over 2 times 72. 2 goes into 72. That's going to give you 36. Or just grab your calculator, throw it into your calculator, guys. 35 times 36. Somebody throw it out on a calculator. Thank you, Gabby. 1260. Thank you, Sarah. Okay. How you guys feeling about this one right here?
Miss Elsie, couldn't you find the difference and then divide that by the last number? Wouldn't that give you the same thing?
Okay, couldn't you find the common difference?
Yeah, at first, and then just divide it by the last number. Wouldn't that give you the number terms?
Okay, would that hold true for every single problem? That's where experimentation, you just made a hypothesis. So now we have to experiment, you know? You have to try your assumption with different problems to see if it works out. If it works out for all your problems, then yes, that would hold true. If it doesn't work out for all your problems, then it doesn't hold true. Okay, let me give you a quick one here. Okay, 1 plus 3 plus 5 plus 59.
Wait, so that's
What would you do with this one? Okay, you see what I'm saying? Well, let's figure out which term this is. So this would be 59 is equal to 1 plus n minus 1 times, what's the common difference? 2. So 59 equals to 1 minus 2 plus 2n. That's a 2 right there. So 59 would equal to negative 1 plus 2n. So we're going to add the 1 to the 59, and that's going to give us 60. 60 divided by 2 would give us the 30th term. Does that work for your hypothesis? Does it work, Lee? Okay, so let me just go ahead and settle this for you. Sometimes it does, and sometimes it doesn't. So to be on the safe side, always go ahead and follow through with the formulas, okay? So don't necessarily assume just because it works on this problem, it's going to work on other problems too. All right, So guys, here we are. We're gonna go back to sigma notation. And we're still looking for the sum, okay? Now, this one here, the lower limit or the starting value is 1. The upper limit for this one is 100, as in the last number is 100. And the formula we use for this sequence, ooh, I think I just wrote that wrong. Yep, I certainly did. Okay, that n belongs inside the parentheses, guys. The formula we use is this. So they want us to calculate the sum of the first 100 terms of this sequence here. So they want us to find the summation notation. So now, because it's in the form of a summation notation, you can actually go on your calculator, guys, and plug this into the calculator. By the way, the previous one we just did, we could have also plugged that into the calculator too. Those of you with the older graphing calculator, after class, I couldn't answer Paige's question. I went on and I did some research, and I found that the sequence as well as the sum with the older graphing calculators is located under the list option. So do play around with the list option. You have to hit second key and then the list, and you should be able to find sequence, S-E-Q, in there, okay? And when you type it in, guys, you got to be careful. So for this one, if we wanted to do the sequence on a graphing calculator, the old graphing calculators, okay, once you hit sequence, it comes up. So we do 6 minus 1/2 x, identify the variable, identify the lower limit, identify the upper limit, and then close the parentheses and hit enter. It will provide every single term in that sequence. Now, if we wanted to do the sum, what you would do is go ahead and look for the sum formula. And if you look for the sum formula, guys, one way to do it is to actually go back and type in the sequence in here, okay? You know, take this, plug it in right there. But another way to do it is to actually go to the sum and then plug in the formula again. 6 minus 1/2 x, comma x, comma 1, comma 100, okay? And you're going up by 1. Make sure you add the additional 1 at the end. And that would give you
How do you separate them?
How do you separate what?
Like how you have it written is you use commas, but how do you separate it on the calculator? How do you distinguish that they're different?
Well, one of them is a sequence that's going to give you individual terms like 2, 4, 6, 7. This one is a sum. It's actually going to give you the total when you add up all the terms together.
I meant when you write it out, you have x, comma 1, comma 100. How do you separate those on the calculator?
Okay, the calculator knows if you're looking for a sum, that's why you indicate this. You grab the sum formula. There's already a formula in there for this page, okay?
Okay,
And
so I just put them all in one continuous one. Okay.
And so there's already a formula in there. So the computer is set up to prompt you for this information right here. And since it already has its formula, it takes your information and plugs it into its formula to get the total for the sum. Sequence, when you talk about the sequence, you talk about the terms individually. So again, it's already got a formula in there that says that I am, by the way, guys, these are computers. They've been programmed to do specific tasks.
However,
So if
it's
it's a
not
sequence,
fucking
it's
working.
huh?
It's not working.
Which one didn't work for you? The sequence?
Not
or
either of them.
what?
Yeah, they just come up as like there's an error. It doesn't work.
All right. Again, I'm going to have to do some experimentation with you after we're done with the session. So hold on to that thought. Make sure you highlight that problem in your notebook. We're going to come back to it later on, okay? All right. So guys, let me finish this one, all right? Because I want to make sure we finish what we needed to. And then I'll work with you later, Paige. We can stay after and work on it. Okay, so now guys, look. This is a summation notation. If you got a graphing calculator that can do it, definitely go ahead and do it on the calculator. But if you don't have a graphing calculator, here's what you do. Find the first term, plug in 1 into the formula. So the first term would be 6 minus 1/2 of 1, which gives you 5/2. And then find the last term. The last term is the 100th term. So you do 6 minus 1/2 times 100, which gives you 6 minus 50. And so that turns out to be a negative 44. Now you go into the formula. S sub n is equal to n divided by 2 times a1 plus an. So you get S sub 100 is equal to 100 divided by 2 times a1, which is 5/2, plus an, which is 44. And you throw all of this into a calculator just to expedite the process, guys. How about we just do this? 5/2 is 2.5 plus 44. Just throw that into your calculator. And what's the total? Because Sarah's giving me 1, Leslie's giving me something completely different. Gabby's giving me 1260, Sarah's giving me 12. Was that the previous problem? Oh, okay, my mistake. That was the previous problem. Okay, all right. So,
Sarah,
uh-huh.
Miss Sarah,
Yes.
you added, it's 11/2.
Oh, Shazam. That's a big mistake. Okay, 11/2. Okay, so rectify that for me, guys. That's 11/2. Good catch, good catch. Okay, so that's going to be 10.5. I mean, I'm Shazam. Okay. That's going to be 5.5 right there. 5.5 right there. Did you guys see that? Is the 44 negative? Yes, it is. But then I plugged it in as a positive. What the heck? Am I rushing here? All right. There we go. And so what you guys get for it? All right, let me see here. Negative 1925. Is that right for the first problem with the 100? With the 100. What do you mean the first problem? This is the same problem. We're just working it out to get the answer. Okay, all right, perfect. Okay, did anybody try it on the calculator using the summation notation? Okay, Sarah tried it. Anybody else tried it? Okay, nobody else tried it. All right, guys. Play around with your calculators, okay? Remember, we're not taking a test on this chapter, but some of these questions will show up on the final exam. So now, I am moving on to 12.3, guys, which is on the geometric sequences. Okay. When we talk about a geometric sequence, remember, this is a sequence, and a sequence is the same thing as a pattern, where each term is found. Okay, we just finished arithmetic. Arithmetic has to do with addition. Now we're into geometric sequences. The geometric sequences have to do with multiplication. So a sequence where each term is found by multiplying each term by a value called the common ratio, and we'll use R for the common ratio to find the next term in that sequence.
Miss Elsa, can you say that one more time? I couldn't understand the writing.
Okay, a sequence where each term is found. Can you see the screen? Yeah? No? Okay. So it's a sequence
I
where,
can't read some of the words.
huh?
I couldn't read some of the words, that's why.
Oh, okay. I wonder if there's an option to caption at the bottom. I'm gonna have to play around with that. A sequence, guys, where each term for a geometric sequence is found by multiplying each term by a value called the common ratio to find the next term. So you're multiplying each of the previous terms by the same value over and over again to get to the next term. That number that you keep multiplying by is called the common ratio, guys. Unlike the arithmetic one, which was D. So now we've moved on to the geometric sequences where it involves multiplication. Now, furthermore, to find the nth term of a geometric sequence, as in to find any term in that sequence, the formula we use to calculate a specific term in that sequence is an. Very similar, we're still using the same variables, okay? Is equal to a1 times, as in the first term, times the common ratio, which I'm going to insert inside a set of parentheses, raised to the n minus 1 power. Now, guys, be careful with this, especially on the calculator. If your R values are negative, that is going to affect, it is going to impact your answer. So be very careful. All right, guys. Can R equal to 0? Can the common ratio be 0, guys? Anybody? Can the common ratio be 0? Of course not. All right, guys. So what in the world am I talking about? Okay, so here we go. Let me go ahead and do an easy one. A1 is -2. And then R is 4. Okay. I want you to list the first, let's say, 5 terms. List the first 5 terms. We have the first term already. That's -2. We know the common ratio is 4. That's the number we multiply each term by to get to the next one. We have the first term, so to get the second term, we multiply the first one by 4, so that gives us -8. To get the third term, we multiply -8 times 4, and that's going to give us -32. To get to the next one, we multiply this by 4, and that's going to give us a -128. And then to get to the fifth one, we multiply -128 times 4. So -28 times 4, that's going to be -400 plus -80 plus -32. So that's going to be -512, guys. How you guys doing? You good? All right. Who said no, no, no? Oh, okay. You were answering the previous problem. All right. Now, the next part of this, I want you to find the 10th term of this sequence, the 10th term. So on this one right here, guys, to find the 10th term, we go into the formula. You could also continue the list until you get to the 10th one, but that's going to be very time consuming. So instead, we go into the formula. We're looking for the 10th term. The first term is -2. The common ratio is 4. And then the term number we're looking for is the 10th one. So we go ahead on our calculators, guys, and we're going to plug this into the calculator. -2 times 4 to the 9th power. Now, let me just say this. Please, please, I implore you guys, type in the problem exactly like you see it, okay? As in -2 times 4 to the 9th. Don't go and multiply 2 times 4 and get 8, and then you do 8 to the 9th. That would be completely and utterly wrong. So just type it in like you see it, -2 times 4 to the 9th power. Give it a try, guys. It's going to be a large number. What's the answer? Ooh, that's a large one. Okay. So it's -5 to 4, 524,288. How you guys doing?
We won't get you out of here.
Excuse me,
The
sir.
last thing I do
Hold
is
on,
get you
people.
out.
Hold on. Okay, sorry, guys. Distractions. All right, everybody. Let's see here. Here's one, guys. Find the 5th term given this sequence right here. Okay. A1 is equal to 5. R is equal to -1. You guys find the 5th term for this one for me. Let's see what you come up with. A1 is equal to square root of 2, and then R is square root of 2. All right. What'd you guys get for that one? A1 is 5, R is -1. You want to find the 5th term. What's the 5th term? Okay, A sub 5, or the 5th term. All right. Now, it looks like, who is this? Paige says -5, Lee says -5, Sarah says 5. So the question is, which one is it? Is it 5 or is it -5? Jasmine says 5. Laura says 5. Let's check. Guys, the formula is AN equals to A1 times R to the n minus 1. So A sub 5 will equal to the first term, which is 5, times -1 to the 5 minus 1 power, which gives you 5, ladies, times -1 to the 4th power. What is -1 to the 4th power? Is that a positive or is that a negative? That's a positive, guys. So the answer, yes, is 5. Okay? Not the negative. So why didn't this one work out for you guys? It's because you didn't put the parentheses around the -1. So you have to make sure you put the parentheses around the -1. All right. Next, you guys try this one right here, okay? What do you get? Oh, I erased the formula. Shazam. What is the answer? By the way, I'm going to try and join Eric Yoon today in a webinar, the owner of this company right here, guys, to see if he can add some emoticons. So if I get a chance to ask my question, what kind of emoticons would you guys like to see on Zoom?
What is that?
On emoticon?
Yeah.
The emojis.
Oh.
Sad face? No. Josh, this is a positive space, okay? Where people come to be positive, be happy. No sad faces, Shazam. No sad faces. A confused face. I like that. A crying face. Nah. No crying. No crying. No crying. We need positive.
What if we want to cry? What if we want to cry in the lesson?
Listen, we want. Oh, Josh, I like that one. Mind blown. Okay, I like that one. Very good, very good. And if I get a chance to speak to him, I am going to say, you know, I surveyed people and this is what they want, okay? No thumbs down. That's -2, Joey. Calm down with that thumbs down. Ooh, I like the way that sounded. Okay, Wesley, come on now. No decimals. Only 6 was no evil faces. That's -2. Okay. Oh my gosh. Okay. Anyways, guys, I like the positive emoticons. I don't like the negative emoticons. Okay. Confused. Huh. Is confused positive or is it negative? I don't know. Confused sounds like a bit negative to me. Yeah. No confusing. Give me some positive ones. It shows we need help. Good point. Good point. But how would that work in industry? Because remember, Zoom is being used all across the nation. This thing went from 6 million users back in January to over 30 million users right now, guys, okay? It's crazy. It shows we need help. Okay, I see your point. The guy with the monocle? Oh, as in I am extremely intelligent. Oh, okay. All right, I can see that. Oh, yes, Sarah, I like that one. The celebration one. Joey, what is up with you and all these negative points? I mean, emoticons that you try. Question mark. Is that a positive or negative? Question mark. Okay, I'm going to think about the confused one and the question mark one. The sick one. Paige, what you... Josh just said the same thing. The sick emoji. Questions are positive. You're right, because I do tell you guys to ask questions too. Okay, I like that, Presley. Okay, with the mask. What is the mask supposed to do, Paige? Josh says it's appropriate for our times, the sick emoji. Oh, okay, I see your point. I see your point, Josh, but...
The mask emoji should be supported the medical people.
Ah, I see you. For Corona, yes, yes, yes. The light bulb, I like that one. Yeah, Sarah, I like the light bulb. Yes, yes, yes. Okay, so I am going to write these notes down and hopefully I'll get a chance to speak to Eric Yoon today. I'm going to find out. I don't even know what time this webinar is. Hopefully I don't miss it. Maybe I should just send out these questions, these points. Okay. I'm going to compile all of it together, guys, and send them out, okay? I'm going to put all of them, okay? Including the ones that are not so positive, like the confused face. Well, the confused face, maybe. The thumbs down, I don't like that one, but I'll put it on the list, okay? That was another one.
How about the evil face?
How about what?
The evil face.
The evil face? Okay, I'll put that. So, guys, listen. This is Zoom. This is completely different than your regular cell phones, what was the other one? Well, no, I'm not even going to mention that to you guys. Instagram. Instagram has one option, love. Okay. What else do you guys use? Snapchat? What kind of
Yeah.
Oh, you guys have a lot of emoticons in Snapchat. What about TikTok? Do they have a lot of emoticons?
I don't use TikTok. I don't know.
Okay, the wink emoji. Okay, I see that. Yeah. Anyways, guys, let me go back to the problem, okay? Because I'm wasting time here. It's 10:13 already. We're almost done. Okay, guys. So A sub 5, or the 5th term, will equal to the first one, which is square root of 2, times the common ratio, which is square root of 2, raised to the 4 minus 1 power. So you get square root of 2 times square root of 2, oh, not 4, Shazam, my mind's moving too fast. There we go. That's 5 minus 1, so that gives you 4. Give me the answer, guys, in simplified form. 4 radical 2, 4 square root of 2. All right, I see those decimals in there. No decimals, students, okay? Now, when you do square root of 2 to the 4th power, guys, that's going to give you 2. So the answer is actually, no, oh, Shazam, that's 4. Ooh, shame on me. Okay, so the answer is going to turn out to be 4 radical 2. And there you are, guys. Okay, let's see. Here comes another one. I'm going to delete this one right here. I want to find the 9th term given 1, -1, +1. Shazam. What are we adding, guys? What's the common ratio? Remember, this is multiplication, not addition. I said addition, I'm sorry. -1. So we want to find the 9th term. Oh, you guys do it. What's the answer? Okay, Gabby says 1. Laura says -1. So let's go into the formula. So the 9th term will equal to the first term, which is 1, times the common ratio of -1. The common ratio, by the way, is -1, what you're multiplying each term by to get the next one. Actually, it's 1. Okay, Laura, you changed your mind. Okay. 9 minus 1 gives you 8. Guys, bottom line is this. When you have a negative raised to an odd power, you get a negative, okay? And then when you have a negative raised to an even power, you get a positive. And there you are. Mom, go to your bed. Oh, Mom, bed. Get on the bed. Bed. Get off the floor. Go on the bed. No? Okay, this dog sometimes. All right, guys, so yes, the answer is 1. If you take -1 to the 8th power, it is 1. Okay, next, let's see. We need to create a formula for this one, guys. It says to find the nth term. Find the nth term given -3, 1, -1/3, 1/9, and so forth and so on. So A1 is -3. What's the common ratio for this one? Not -3. Aha, -1/3. Very good. So you plug in your common ratio and raise it to the n-1 power. And that's your nth term formula, guys. You good? All right, next, we're going to find the sum of the first nth term of a geometric sequence. We're going to find the nth term, the sum of the first nth terms of a geometric sequence. Now, the formula we use for this one, guys, be very careful, is S sub n is equal to A1 times 1 minus r to the n over 1 minus r. Now, I want you to take a moment and write it down. I'll show you another way you could also write this. I'm sure some of you figured it out. Actually, you know what? Let me just go ahead and squeeze it right here. So A1 times 1, that's a 1, minus r to the n, and all of this would go over 1 minus r. That's the exact same formula. It really doesn't matter how you write it. All right, guys. So here comes a question. Let me see here. Let me find a good one. Find each sum. You know what? Let's do one of these. Clear this. Okay. Let me see here. Okay, I'm getting on echo. I need to stop saying All right, guys, here's one. This one is in sigma notation or the summation notation. The lower limit is 1, the upper limit is n, and the formula is 4 times 3 to the k minus 1. Now, remember, you need the r value. What's the common ratio for this one, guys? The common ratio is 3. Now you need your first term. What's the first term for this one? The first term is 4. Now, to find the first term, guys, you just take k equals to 1, plug it into the formula. So you do 4 times 3 to the 1 minus 1. 1 minus 1 is 0. Anything raised to 0 power is 1. I mean, yeah, 1. 1 times 4 gives you 4. That's how you get the first term. Now, we go into the formula. S sub n is equal to a1 times 1 minus r to the n over 1 minus r. So we get S sub n is equal to 4 times 1 minus 3 to the n power over 1 minus r. What is r? 3. So we're going to go ahead and simplify this out. So this one turns out to be S sub n equals to 4 times 1 minus 3 to the n all over negative 2. Now, should we leave that negative in the denominator? Should we leave it in the denominator, guys? Yes, no. Anybody, somebody? No, we do not leave it in the denominator. So when you rewrite this, guys, just to expedite this, I'm just going to go ahead and remove it from down here and just move it up here. All right. Now, could you simplify this further? Absolutely. You could distribute the negative 4 and then simplify a little bit more. But in distributing the negative 4, it makes it a little bit more complicated. So I would just leave it just like that. So this is just a general term formula because it didn't ask us to find the sum of any specified number of terms, okay? So now, guys, let's see here. Let's do this one right here. Let's find the sum of this one, okay? And we want to find the sum of the first 7 terms of, let's do 1, 1/2, 1/4. So we need the first term, A1, which is 1. The common ratio, what's the common ratio for this one, guys? 1/2. Okay, so we go into the formula. S sub n will equal to the first term, which is 1, times 1 minus r, which is 1/2, raised to the 7th power over 1 minus 1/2. So on this one, we're basically going to end up with 1 minus 1/2 raised to the 7th power. I would put this in parentheses right there, over 1/2. So you plug this into your calculator to get your answer. Now, is this answer going to turn out to be a positive or negative, guys? Yes, Gabby, you can definitely do that. On the previous problem, I didn't see that question. Yep, you can definitely do that. Okay, so that would have given you 2 times 1 minus, what was it? Oh my goodness, I forgot what it was. Shazam. What was that problem? Oh yes, 3 to the k minus 1 power, something like that. Okay, yeah. All right, guys, did you all plug this into the calculator to find the sum? Anybody? Okay, Sarah got 127 over 64. Did you guys get that? Yes? Okay, perfect. All right, very good. Okay, here's the last part of it, guys. And that is the infinite geometric sequence. Well, actually, no, actually, they use this term right here, series. So we've been chatting about these sequences where the number of terms, guys, could be finite. But when we talk about an infinite geometric one, in this case, a series, these terms, they typically go all the way up to infinity. So when it comes to the infinite geometric series, guys, either they are going to converge or they are going to diverge. Now, converge, when a geometric series converges, that means that the sum will approach a certain value. It will approach a certain value. It will go to a certain value. However, when it diverges, it doesn't go to a certain value. In other words, if a geometric series converges, you can find the value of it. And so if it doesn't converge, we say that it diverges. Now, in talking about these guys, the formula, the summation notation for an infinite geometric series is this. The lower limit is k equals to 1. Rather than having an n as the upper limit would be infinity. All right? By the way, remind me to do one little word problem with you guys before I let you go, okay? And so the formula is a sub 1 times r to the k minus 1 power. Now, for these guys, be careful. In order to determine if one of these infinite geometric series is going to converge, okay, in order for it to converge, the formula we use is, well, first you got to decide, in order to determine if it is going to converge, you look at your R value, the absolute value of it. If it's less than 1, it is going to converge to a specific value. And to find that specific value, the formula we use is S sub n is equal to A1 over 1 minus R. And as I said before, if an infinite geometric series doesn't converge, then it is said to diverge. So therefore, it would not have a value if the series is going to diverge. So the only time you have to find a value for the infinite geometric series is if it converges. In order for you to determine whether or not it converges, you have to look at your ratio. If that common ratio is less than 1, yes, it is going to converge. And yes, you can find the value of that geometric series, infinite geometric series. All right, guys, so how do we find that value? All right, let's go ahead and practice a little bit. Here's one. You have to first decide, oh, is this one going to converge or is it going to diverge? So here's the first example. 8 plus 4 plus 2 plus dot, dot, dot. As in it keeps going on and on to infinity. All right, guys. So looking at this one, what do you look at to determine if it is diverging or converging? The ratio.
So even if we're doing geometric, they still could have the addition signs?
Yes, absolutely. We're looking for a sum. Remember, S stands for sum. Okay? So yes, you can add all the terms. You can find the sum of all the terms in an arithmetic sequence as well as in a geometric sequence. Now, on this one right here, guys, what's the common ratio? 1/2. So since your common ratio is 1/2, this means that this series here is going to converge. So what value is it going to converge to? If you keep adding up all the terms in this sequence right here, guys, it is going to approach a value. What is that value? So to find that value, we will use this formula right here. S sub n is equal to 8(1) over 1 minus r. So you would do S sub n is equal to A1, which is 8 over 1 minus 1/2, the common ratio. So you just grab a calculator and throw this on a calculator. What does this one come out to, guys? Anybody? All right, 16. Does that make sense, guys? We're good?
So 16 is like the answer.
Okay,
like,
Gabrielle said no. Okay. Oh, wait, yes. Okay. Ask me a question if you're not getting it, guys. All right, so I'm gonna move on to the next part of this. Now, remind me to do that example problem with you guys. So here comes the next problem. This time it is, let's do this one right here. Let's go ahead and do the summation notation. So the summation notation is this. The lower limit is 1. The upper limit obviously is going to be infinity because we're talking about infinite geometric series here. So what does that represent? The 16 is the value. Okay, the 16 represents precisely the value of the infinite geometric series. So if you were to take all the terms in that infinite geometric series and add them up together, the sum will approach 16. We'll get to 16. All right, guys. So here's the next one. 5 times 1/4 to the k minus 1 power. Okay, let's go ahead and give this one a try. First, we have to decide if this one going to converge, diverge. How do we know? We find the common ratio. What's the common ratio for this one, guys?
1/4.
1/4. So then you go into the little formula. What's the first term, by the way? What's the first term? The first term is 5. So we go into the formula, guys, and we plug everything into the formula. So when you go into the formula, it's going to be S sub n is equal to A1, which is 5. And we're going to divide it by 1 minus 1/4. Okay, you guys go ahead and throw that into a calculator, please. Give me a fraction, guys. I don't want any decimals. All right, Gabby, very good. 20/3. Hold up a second. Let me see here. I'm looking for another one, guys. Ooh, I'm liking this one right here. So let me go ahead and do this one quickly. And then I'm going to do a little word problem with you. 8 plus 12 plus 18 plus 27. All right, guys. Talk to me about this one right here. What's the common ratio? Is it going to converge or is it going to diverge? Converge or diverge? It is going to, okay, Laura, very good. The common ratio is 3/2. Is it going to converge or is it going to diverge? This one is going to diverge. So do we find a value for it? Nope, it doesn't have a value because it's diverging. The only time you'd find a value is if the infinite geometric series converges, as in all the values are approaching one number, that one number, the sum of all those values will approach that one number. What is that one number? And so that's what you use the formula for, guys. All right, now here's an application, guys, because I know I haven't been doing too many application problems with you, but there are quite a bit of application questions in here. It's just that I'm trying to get all the information to you, but we did not do any of these. Some examples of these, guys, has to do with retirement accounts, your savings. Well, you don't even know what a tax sheltered annuity is. Your salary increases. Okay, there's lots of different ones. But here's a quick one. Let's say somebody comes up to you, okay, on the first day of the month and gives you $1. And then On the second day of the month, they double it, so you have $2. On the third day of the month, they're going to double the previous day. So on the third day, you would have what? $4. On the fourth day, oh, let me write this stuff down. Okay. So on the first day, you have 1. On the second day, you have 2. On the third day, you're going to have 4. On the fourth day, remember we're doubling, okay, doubling. On the fourth day, you're going to have $8. We're doubling, then $16 and so forth and so on. The question is, how much money will you have on the 15th day? How much money will you have on the 15th day? How do we calculate how much money we have on the 15th day, guys? What formula do we use? Just tell me. Anybody? Are we looking for a sum or are we looking for a specific term? We're looking for one term, okay? Just one term. We're looking for the 15th term. By the way, guys, is this a geometric pattern or is it an arithmetic pattern? Arithmetic or geometric? This is geometric because we're doubling every single day. Very good. All right, so we're going to go into the formula an equals to a1 times r to the n minus 1. So a sub 15 or the 15th term will equal to the first day, guys, the value of the first day, which is 1, times r. What is the common ratio for this one? 2. And we're going to raise it to the 15 minus 1 power. So essentially, we're just drawing 2 to the 14th power, and you throw that in your calculator, let the calculator do it for you. So somebody throw that on the calculator, please. Okay, so the total would be 16,384. Now, wait, there's more, guys. So the next part of this would be, what is the sum of the first 15 terms? Find the sum of the first 15 terms. Find the sum of the first 15 terms. What's the sum, guys, of the first 15 terms? Well, the formula we use for that is S sub n is equal to a1 times 1 minus r to the n power over 1 minus r. So you go into your formula, S sub 15 is equal to the first term, which is 1 times 1 minus r, which is 2 raised to the 15th power over 1 minus 2. So in the numerator, you'll be left with 1 minus 2 to the 15th. And then in the denominator, guys, 1 minus 2 is a negative 1. Negative 1. Somebody plug that into a calculator. How much money is that? Shazam. That's a lot of money. $32,767. And there you are, guys. So essentially, on the 15th day, you had $16,000. Remember, this is doubling. So the 32,000 is double that amount. So all the amounts you earn from the first day to the 14th day, you add it all up, and then they double all that. All right, guys. I am done.